Finally, we've reached our last topic, which is fatigue. So fatigue occurs when you have cyclical loading. It can lead, again, similarly to creep, to catastrophic failure at lower applied stresses than what we would predict from our fracture. So you could have fatigue with no pre-existing cracks, and you'll typically have a maximum stress, a minimum stress, and a change in stress. So you could have low cycle fatigue where they fail at less than 10 to the 4th cycles. High cycle fatigue will fail at larger than 10 to the 4th cycles. And you could develop a relationship for fatigue for no pre-existing cracks. A lot of these are empirical relationships with kind of predefined constants. You could also solve for fatigue by summing, using actually Miner's rule, and summing kind of the cumulative damage from the different levels, or if you're changing essentially your stress levels. You calculate what would be the number of cycles to failure for that particular stress level, and you sum those in order to find the value. But typically every material will have pre-existing cracks, and to do that, or to study those, you can look at the number of cycles to failure. So you can look at the crack growth rate as a function of the number of cycles. So your typical cyclical or classical fatigue, you can characterize with your stress ratio, which is your minimum stress over the maximum stress, and we can estimate the number of cycles to failure, or the number of times it takes for your critical crack length to grow to be catastrophic crack length A sub C. You can calculate A sub C depending on your maximum or your delta sigma or your delta stress value using your fracture toughness. So there's also three basically regimes. So slow growth, basically mid growth, or the Paris law where we want to work in, and then high growth. High growth, we can't do anything. Paris regime, that's where we're going to study, again, kind of that constant growth rate. So we could actually take that expression for your Paris regime, and exactly, high cycle you're done. And you can integrate, and we can get an expression for the number of cycles to failure as a function of your initial crack length, the critical crack length, and the applied stress. Oftentimes, you'll also look at these SN curves for fatigue. So depending on your stress amplitude, your delta sigma, you can see how many cycles to failure it will take. So you see that the green will fail first, then blue, then red for a particular stress amplitude. You may have some stress values where it never even basically crosses. So that will not fail for the green or the blue as far as we can tell in our graph. So that is fatigue, and I hope you've enjoyed mechanical behavior materials. See you next time in another course.